Namaste everybody. I am Rohit Kumar Bisural. I was project in charge of the Naranghat Muglin Road project at that time, and now I have recently transferred to Coastal Road project as a project director. So I would like to put our experiences, what we have done and how we experienced from the slope stabilization works in Naranghat Muglin Road project on past few years. This Naranghat Muglin Road project, as all of us know, that the entire road alignment passes through the Mahabharat Himalaya mountains, and out of 33 kilometers of Naranghat Muglin Road project, whole road stretch was upgraded to Asian Highway standard in 3 ICB contract packages between the 2015 and 2018. The road was widened from 7 meter. Earlier the road was 7 meter wide, and it was widened to 10 meter in the hilly parts. And in the plain and rolling terrain, it was widened to 11 meter. Large number of landslides happened there with road closures up to 47 hours at a time. So while the project was road construction upgrading was going on, the road was closed for 47 hours, even up to 47 hours at a time. And DOR and Donor World Bank realized that countries should pay special attention and provide slope stability measures in order to prevent people's life and preserve valuable assets. So here is a rough economic loss analysis due to road closure at Naranghat Muglin Road on 2018. We can see the vehicle types in the first column: truck, bus, and light vehicles. Number of vehicles was counted at the Naranghat Muglin Road itself, and number of passengers. This tentative number of passengers on each type of vehicle. Hourly wage of one passenger. You can see here the rate of passenger, and average loss from one vehicle in 18 hours of traffic jam. So the total loss, economic loss in Nepali rupees is due to truck, haltage of truck say, and due to bus and due to light vehicles, all it comes out to be 21 crore 11 lakhs 13,000 for 18 hours of a traffic jam. So 50% of this goes to the Indian economy. The loss to the Nepal and goes to the India. And so economic loss per hour is rupees 1 crore 17 lakh 28,000 per hour. So I would like to show you some successful examples of slope stabilization works applied in several locations with extensive bioengineering measures at specific 39 places, with specialized works of rock netting at 8 places of 24 kilometer hilly section of Naranghat Muglin Road. This is geological map along Muglin Jugedi Road section of Naranghat Muglin Road, because Jugedi to Muglin comes under the Mahabharat range. This is one of the road construction practice in Nepal, showing the comparative study for rural road and Muglin Road. This is maybe not in Muglin Road, but for all the national highways in hilly parts of Nepal. Here the condition one is existing natural slope is like this, and the shear zone is very deep here in the rural road, and in Muglin Road the shear zone is cut by the road section itself. The condition, second condition here is in rural road, slip surface of huge old landslide is not active here. The slip surface is below the road section, and in Muglin Road or most of the national highways with wider road section, the bedrock is cut by the road. Here I have shown one of the photograph of slope failure in the Nariat Mungin road itself. This is one of the problematic section of Nariat Mungin road, which is at present it is controlled by this slope trimming and rock netting technique. This is one of the problem site of Nariat Mungin road, where the rock mass is sliding from its joints. For the slope stabilization works in such type of roads, we have found that the following engineering studies are required. So the first one is detailed topographical survey with 1 meter contour intervals in a scale of 1:500. Monitoring of movement of all anchor blocks during the study periods. Engineering geological mapping for in 1:1000 scale. MASW, MAM and SRT survey works. Slope stability analysis using appropriate software. And the solution and studies are the includes rock bolts, rock nets, toe wall, drainage, soil nailing and bioengineering measures. Usual survey works such as topographic survey, drone survey, engineering geological mapping, etc. will be required at such sites. So here I am presenting the bioengineering solutions. So many number of bioengineering techniques are here, starting from 1 to 7. The first one is trimming of slopes and overhanging area should be done as necessary. In some cases, the backfill slopes are needed to be trimmed at 15 to 20 degrees. At the present slope, it is steep and unstable. Second one is water flow system should be carefully considered from the slopes, both for seepage water and surface runoff. Third one is the facings in existing reels and shallow gullies are necessarily required, with some live check dams in between. Fourth one is brush layers should be in diagonal in about 10 degrees slope towards the natural gullies, reels, facings. Fifth one, the stone or boulder riprap in deep gullies are generally required, including live check dams where necessary to break the water velocity. In check dams, the middle portion should be lower than the sides so that water will not erode the sides of the check dam. Sixth one, the plantation of local grass such as sito, kaas, salimo, khor, simali, khor in between the brush layers in diagonal pattern as brush layers over jute netting is recommended. Seventh one is live cutting and plants used are to be from local areas so that the survival rate will be high. Bioengineering solutions. The eighth one is jute netting may be required with use of live cutting pegs in steep areas with loose soil materials. Grass seed spreading is recommended in areas over jute netting or open rocky areas. 10th one is the plantation of only shrub trees in HS hillside slope is recommended. Mango and other big tree plants needs to be removed to valley side slopes if planted already in hillside slopes. 11th one, use of bamboo crib walls in slopes where necessary to retain some materials. Earth is recommended. Bamboo crib walls are recommended in layers, especially in the valley side slope where disposal are made. Use of wattle fence in upper part of the disposal or valley side slopes where materials are loose are recommended. Use of dry walls riprap with live cutting pegs where small slopes are to be retained or supported are recommended. Use of subsurface drains in various slopes where there are high seepage water. These are the bioengineering techniques that we have used in Nariat Mungin Road slope stabilization works. Here I have shown typical section of study and suggestions. The problem identified at this section was in fault gauge black clay with graphite is seen over here, and suggested measures for slope protection was scarify loose materials, construct RCC retaining wall, provide wire mesh and rock bolts with proper weep holes. The slope stabilization measure is already done at this section. rock netting and bioengineering works at Kalikola section. I have shown one of the rock netting works we have performed. This is Kalikola section. The earlier, while we completed our rock netting works, it looks like this first picture. And after a few months, say 3-4 months, the same section was looking like this one. Here I have shown the rock netting works in progress by the workers on the hillside. And this second picture shows the scaffolding works that is necessary while constructing the rock netting works. This figure also shows the slope trimming works on the steep hills of Nangat Munding Road. Both of these figures show the same thing. Here the workers are in the vulnerability of this getting accident, so they have been provided with the safety ropes. Here in this section, this plumb concrete wall is provided along with the rock netting above the wall here. We cannot see it clearly, but the rock netting is also provided above the plumb concrete wall. Here also this bioengineering and rock netting combined approach is done on these two sections. This is the kilometer 27 plus 400, where we have provided the bioengineering works with this water, this collecting channels on the herringbone pattern from the two small this streams, and the same site has been converted to green, and now it is even covered with the bushes. If we visit this site, we cannot identify this failure site. The site is already stabilized. This is one of the jute netting works with live pegging in the Nangat Munding Road, and the other one is this retaining wall with this bioengineering bushes. This is the completed road section with structural and bioengineering works after 1 year. This also is the completed road section with structural and bioengineering works. From this, we can draw a conclusion that the specialized work of rock netting with bioengineering has been successful, and no further slope failures and road closures took place in these specific sites after interventions just before the monsoon of 2018. Thank you.